Good evening, everyone. Um we will wait for 1 or 2 minutes if someone joins, otherwise, we will start. So, yeah, let's start today's session. Good evening, everyone. Myself, Yashvi. Um Today it is the third live session for the course Environmental Pollution. Just a second. Can you see my screen?
Yes.
Okay. So today it is the third live session for the course Basic Environmental Engineering, Pollution and Abatement. So, do you have any doubt like in the previous lecture? Anyone? Okay. So if not, then we will start with the uh, next week lectures. So basically, in the previous week we had discussed what was pollution, what types of pollutions are there, what type of contaminants are added because of few natural activities and few man-made activities. So after that, since there is continuous rise in the industrial activities and human intervention that has caused continuous adding up of the pollutants into the environment. So there are various guidelines made so that it will guide us to uh, on how much we can discard or how much we can add in the environment so that the hazardous impacts are minimum. So for example, if you have um, carbon dioxide in the atmosphere, then there will be some limit, like for example then like if it is a residential area and some amount of carbon dioxide is present in the vicinity, then government or CPCB for India has set some guidelines on what carbon dioxide concentration is allowed in the vicinity or in residential areas, so that it is not harmful to the living organisms. Okay. And it depends on for example, the guidelines that will be set will be dependent on what is the age of the particular human being, or whether it is male or female, or whether it is whether he or she is having any already disease he or she is having. Based on that, there will be some guidelines made. So in this week particularly, we will be discussing on what quality and what standards do we need to follow for various pollutants present in atmosphere, and some of the techniques how do we measure these pollutants, so that we will be able to find it out and we can have some remedy for that. So firstly, starting with air quality standards. So if human has not provided any intervention, then what should be the standard air quality? Or if even if we want to, like, even if there is some discharge from nearby regions, then those industries need to have certain discharge standards such that these air quality is maintained in that particular region. So depending on the type of pollutant, it can be primary pollutant or it can be secondary pollutant. So primary pollutant are the ones which are directly produced, or secondary pollutants are the ones which are produced when there is some kind of interaction between primary pollutant and the air components. So these are the types of pollutants present, and there are some standards that are set by national ambient, like as per national ambient air quality standards. So there will be some standards for CO2, for CO in which should be present in the atmosphere in microgram per uh, uh, liter of air, or this can be the unit of the concentrations of that particular pollutant. So this now what standard they have made, it varies from region to region. And say for example, you have industrial area, you have residential area, you have no like some other region, say for example you are doing agriculture there. So depending on what region, the all the regions will be categorized. Say for example, this is A, B, C. So depending on what type of region you are looking at, then depending on that there will be some standard that needs to be followed. So list of all these standards that should be followed has already been provided to you, and you do not actually need to remember that, but this is just for your information. So do you have any doubt so far? Okay, so let's move forward. So next is coming to water quality and its standards. So basically what pollutants are present in water, they can be in the form of as we have discussed in the previous class, physical, chemical or biological pollutants. Physical pollutant can be in the form of total suspended solids, which results into water being hazy, and like it, you will not be able to clearly visualize, or light will not be able to pass through that hazy or translucent water. So in that case it causes water to be turbid. There can be some solids which are in dissolved form, there can be some temperature, taste, color, odor. So any pollutant which is which you can visually see or you can feel, it is kind of physical pollutant. Then there can be some chemical pollutants like BOD, COD, heavy metals, total organic carbon, etc. There can be some microbes. So so CPCB has set some guidelines for the disposal of these pollutants from industry. They have even set guidelines for drinking water, like what should be the limit for drinking water, what should be the guidelines in the water bodies, what should be the permissible limit if you want to use water for agricultural purpose. So depending on various activities, CPCB has made guidelines. Okay, and depending on that everyone has to follow, so that the risk that are observed due to any of this pollutant can be minimized. Because say for example, if you take some water and it is not clear, or the color of that water is somewhat yellowish, okay, so obviously no one will drink that water. Or if some foul smell is coming from that, obviously you will not drink. So these are aesthetical parameters. So similarly there are some standards made by CPCB which needs to be followed. Now moving forward, basically water has like natural water has calcium, magnesium, potassium, sodium as the ions present, like these are the cations, and mainly the anions would be bicarbonate, carbonate, sulfates and chlorides. So all these are the salts which are present naturally in water. Now if you look at this chart, then you can say that what there can be some different combinations like CaCl, Cl2, CaSO4, there can be MgCl2, MgHCO3, NaCl, NaHCO3 and so on. There can be number of combinations, like all possible combinations can be made in water. But overall if you see the summation of all the like all the ionic charge due to cations and summation of ionic charge which is due to all the anions, it is always like, if you do the summation of charge, like anions would have negative charge, cations would have positive charge, then it should always be approximately equal to 0. So 5% error is acceptable, but in water there needs to be ion balance in the form of cations and anions. So these you need to check. So now these ions are like mainly calcium and magnesium, they are found to cause hardness in water. Now can anyone tell me what are the drawbacks, like what are the drawbacks due to hardness?
More soap is required for cleaning job.
Yeah, so as you know that hard, soap is required to clean any dirt from any substance. Okay, so if there is more and more of calcium or magnesium salt in present in water, then what it does is it tries to bind with the detergent or the soap you are using. So in that case less and less froth are formed, and less efficiency is obtained, like it will not be able to provide cleaning efficiency or cleaning nature. So in that case hardness will reduce the efficiency. Also it can provide scaling on the pipe surface, like through which water is passing, because there is some solubility of each of this salt, and if the amount of salt exceeds, then there are chances that the salt deposits, like it forms precipitate and it deposits over the surface of pipe. So in that case there are chances of scale formation and so on. So hardness is not like advisable. So there can be like hardness can be divided into two types: carbonate hardness and non carbonate hardness. Carbonate hardness are the ones which are which are of obviously calcium and magnesium salt. So cations are fixed, but in anions there these can be due to HCO3 minus or CO3 2 minus. So these are temporary hardness because these can easily be removed by boiling the water if these salts are present. So these can be removed, but if it is present in the form of sulfate or chloride, then we need some special method like lime soda process or some ion exchange, so that these hardness can be removed. So temporary hardness are the ones which can be removed by boiling, and these are also known as carbonate hardness because it is caused by bicarbonates and carbonates. And non-carbonate or permanent hardness, which are caused by sulfates and chlorides. So it is like which requires some special treatment. So this is all about hardness. So you need to always um, calculate total hardness of water. So if you need to check whether water is suitable for drinking or not, there is some table also given to you in the slides. by professor, in which the water can be classified as very soft, moderately soft, very hard, depending on what total hardness you are getting. So total hardness is nothing but carbonate hardness plus non-carbonate hardness. Okay, so there is some calculation for all for this total hardness, for which a sum has been solved. So you can ask the doubt if you have in that anytime. Now moving forward, another type of problem that can occur is due to suspended solids. So suspended solids, obviously it causes, as I said, turbidity. So what, like, how is turbid water not good? Because the particles that are present in water, it remains suspended, and when light tries to pass through that water, so it will scatter that light, okay, and it will make it hazy. Otherwise pure water is quite transparent. So in that case such water is not advisable for any further usage, or if you use such turbid water in some application, then there are chances that it settles down or it deposits. So you need to check what for what usage you are using that water, or for what application you are using, and you need to have a measure of turbidity. Can anyone tell me what is the unit in which how we measure turbidity? So yes. Okay, so it is nephelometric turbidity unit, NTU it is known as, and NTU is the measure of turbidity of, like, how turbid is the water sample. So mainly, like, it should not be turbid for drinking water purpose, or the turbidity should be 0. So moving forward, next is continuing with the water quality. So as I have mentioned that depending on what like for what we are defining the standards, it can be divided into various types, like whether it is residential, whether it is used for drinking water purpose, or whether it is for discharge. So depending on that, there are A, B, C, D, E criteria, and standards are given for that. Now if the water is to be used for irrigation or for agricultural purpose, then what amount of sodium, calcium and magnesium is present in that water, it is very important, because if more and more sodium is present, then it is found to create problems, because sodium ions will come in between the soil, or it will just surround the particles present in the soil, and which will result into reduced filtration or reduced flux of water, reduced conductivity, and also can cause rusting. So what we need is lesser amount of sodium as compared to calcium and magnesium in the soil or in the water used. So there is one ratio which is known as sodium adsorption ratio. So it is a relative amount of the sodium present per unit amount of calcium and magnesium present. So it is sodium ion plus under root. So now these concentration needs to be in equivalent, because the valencies of sodium and calcium and magnesium are different. So milli equivalent is advisable, like it has to be used in milli equivalent, and there are some standards given, like for example what should be the ratio, so that this water is used for can be used, or it is suitable for the given application or for agricultural purpose. So this is all about sodium adsorption ratio. Now coming to industrial effluent standards. Now industrial effluent standards, as you all know that depending on the type of industry, so from industry to industry there will be some certain different amount of quantity of water generated, and also the quality of water will be different. Okay, so for example, there will be standards set for all the industries. Say for example, iron and steel industry, pulp and paper industry, and so on. So for all different industries there will be different standards set for. Say for example, iron and steel industry releases a lot of amount of Fe, or there will be some solids also, because there will be a lot of mining occurring. Then there can be some heavy metals, then there can be pH of water. So all these are just the example. Okay, so for all this, depending on type of industry there will be some standards. Now it can be different for different industry also, and also the quantity that is maximum allowable. Like for example, for pulp and paper industry, maximum allowable is I guess around 170 meter cube per ton or so of paper produced. And similarly for iron and steel industry, so there will be certain quantity of wastewater generated per ton of steel produced. So likewise there will be some standards for quality and quantity of generation of water. So this load based standard is the same, like depending on what quantity you are manufacturing. For example, you are manufacturing 1 ton of paper, then what meter cube of water is wastewater is allowed to be generated for that industry. Then concentration based generation is nothing but, say for example, if Fe is released from any industry, then there will be some standard for Fe release in the form of ppm. So whatever may be the quantity of water, the ppm or the concentration of Fe in that water should not exceed this concentration. Okay, so now moving forward to noise pollution standards. So noise pollution, as I mentioned in water and air quality standards, that different regions are set for setting these standards. So for noise pollution also there are various standards. Say for example, industrial area, then there can be a residential area, there can be no like silence require, the area where silence is required. So such areas, so 4 areas are categorized, and depending on that, during day and night time there will be some standard for the amount of noise level accepted in decibel. So this is the unit of noise on how we measure. So this much decibel will be allowed in that particular region. Exceeding this is not good and it is not allowed. Then there are standards for vehicular pollution also, because vehicles also emit carbon dioxide, SOx, NOx, because fuel is used. So there are standards for what kind of fuel should be used depending on the C10 number or octane number, and based on that there will be some emission, because good fuel will result into such kind of lesser emissions. And there can be a standard for engines also, which type of engine should be used so that lesser emissions and more complete combustion can happen. So such type of standards has been set, and those should be followed. Now if these are not followed, then there are various audit teams which regularly monitor the effluents or the concentrations in the city of water, of air, and noise, etc. And if it is not followed, then there are some plenty of amount charged, or the company or whoever is responsible, they will be fined for that cause. So this is how nowadays government is very stringent for all of this. Now moving forward, yeah, anyone has doubt so far?
No, ma'am.
No, ma'am.
Okay. So moving forward, next we are coming up is how do we measure, because we need to know what is the quality or what is the quantity of each element or each compound in any of the phase. So there are various ways through which we can identify what is the quality. Quality means what type of material or what type of chemicals or compounds are present in any phase, may it be air, may it be water, or may it be soil. Or quantity means what amount of it is present, because both are important. Once you identify what is present, you need to know what amount is present, because some amount is still acceptable to our bodies and environment also. So you need to know quality and quantity both as well. So there are various ways to know the quantity of any material. One, like very basic method, is volume. You check the volume, or you need check the weight difference. You can check the density difference. You can, by that you can get the idea. But to have proper instrumental method or instrumental analysis, there are sophisticated instruments or various instruments available through which you can check the quality and quantity of any particular compound you are targeting through any of these methods. So first category of method is electrochemical method. So this is the basic method through which you check for the pH, you check for the oxidation reduction potential, you check for the conductivity of water, you check for the dissolved oxygen content, and so on. So can you tell me what, like, why do we check the conductivity of, like, what is responsible for conductivity of water?
Cation and anion.
Yeah, so the ions that are present in water, they are responsible for the conductivity in water phase. So you check the conductivity, and more the ions present, more will be the conductivity. So depending on that, we can get the idea how what is the amount of salts present in water. Okay, so there is, because there is some standard for total dissolved salts also in water, or TDS also in water, which is used for drinking purpose or any application. Then there can be some other analysis, or there can be some another technique which is based on some chromatographic separation technique, where you utilize or such analysis are nothing but gas chromatography, high performance liquid chromatography, ion chromatography, etc. So we will discuss this in detail in the next coming slides. Then there can be some spectroscopic analysis, which is based on UV visible spectrophotometer. There can be FTIR spectroscopy. There can be atomic absorption spectroscopy, and there are some other techniques also, like XRD, which is nothing but X-ray diffraction. This is thermogravimetry analysis. There can be BET. So all the instruments have their own usage. So depending on what we target, we will use the particular instrument. So starting with the chromatographic method. So chromatographic methods are all nothing but, if you have a mixture of compounds, then depending on their mobility in a particular phase, then chromatography is nothing but you separate the mixture into its components. Say for example, it is having A, B, C, D, then there will be some different mobility of A, B, C, D. So you separate A, B, C and D, and then you measure what amount or what amount of A, B, C, D is present. So this chromatography meaning itself says you separate the components present in the mixture. So first type of chromatography is gas chromatography. So here it says that uh, firstly what we do, if we have a mixture, then we heat it so that it is vaporized. So it is mainly used for volatile compounds because they are easily vaporized. Otherwise the ones which are not easily vaporized, we will not be able to use, because there will be certain limit for which how like on which we will be able to supply the heat. So this is used specially for volatile compounds. So what happens here is, you separate, like you inject the sample here, and there will be a tubing. Okay, so it can be in the form of this, like this. So here you inject, it will pass all through this. So in this column there will be a stationary phase and there will be a mobile phase. So here in gas chromatography, the mobile phase is nothing but a carrier gas. So depending on the interaction of each of the components which are present here in the sample, there will be certain depending on whether it is polar, whether it is non-polar, it will be very distinct for each of these component in the mixture. Okay, so depending on the interaction with the stationary phase, the rate at which the any particular component it passes through uh, through the column with this carrier gas, it will be different. So you, after certain time, you will be able to notice that all the phases or all the components in the mixture are separated, and once they are separated, you have one analyzer here at the end of the column, and you measure at what time what component you are getting. So more the interaction with stationary phase, more time it will spend in the column, and it will be obtained later. So there are various detectors for this. So chromatography is just for the separation. You need to have one detector so that you will be able to measure this. So one of the important detector is mass spectrometer. So here what you do, say for example this is one sample, so you ionize this sample, and once it is ionized, based on what mass of each element, based on mass of each element, it gives you uh, it has its own library, and it gives you what is present in this component. So that data you can obtain depending on what mass of the component is there in the mixture. So this is the detector which is used. Now once you get that data, that computer will give you the data in the form which you will be able to understand. You will get such type of peaks. Okay, so this is all about gas chromatography. Then there will be high performance liquid chromatography also. So this is used for the ones where GC cannot be used, because GC we have volatile compounds and we will not be able to use for unstable or which has very high boiling point. So in that case what we do, we use liquid chromatography. So here also there will be one mobile phase which is a solvent, and there will be one stationary phase. So depending on the interaction between the sample and the sample with stationary phase and the mobile phase, there will be different rate at which this sample will travel, or the components in the sample will travel, and you analyze at the end. So here the difference between two mainly is what type of stationary phase and mobile phase you use in each of them. Now moving forward, next is the spectroscopic methods which are used to quantify any particular compound or any particular element in any phase. So spectroscopic method is itself, like the name itself suggests, that it utilizes the amount of interaction that is made between the sample and the radiation. So here what you are doing is, there will be some tendency of any sample to interact with the light that falls on it. Okay, so depending on what type of interaction or the amount of interaction, you try to quantify the material or the one you want to check. So first is UV visible spectroscopy. So this is the schematic for UV visible spectroscopy. UV visible itself says that what radiation range you are using is UV and visible. So say for example you have a sample in which, like, the medium is water and you have certain solute present in it. Now this solute, depending on its electronic configuration, it will absorb certain amount of light depending on its electronic configuration, and it will excite by absorbing the light which falls on this. It will absorb certain light and it will emit the remaining one. Okay, so depending on what amount of light is absorbed, it will calculate like the absorbance for that particular wavelength. Like it will do a wavelength scan, so it will emit all the wavelengths 200, 210. There can be less gap also. So there are chances that it, let's say it absorbs 350 and rest all it does not absorb, or it absorbs very less. So in that case what we do, we measure what amount of light is measured at 350 wavelength, and we can take the difference between what light is absorbed by reference material or blank material. Like for example here, if you have water and solute, then there can be some absorbance of water also. So you need to subtract what is the contribution of water for the absorbance and from the one which is having sample. So you need to have the difference. So you measure what amount of light is absorbed by both of this, and then you check what is absorbed. So you will plot one calibration plot for the known concentrations. Firstly, say for example you have 1 ppm, 2 ppm, and you for that you will plot the curve for absorbance versus concentration, and you will get a linear curve, and you will have y equals to mx plus c. Now based on this, when you have an unknown sample, you will know the absorbance from this spectroscopy method, and you can back calculate what will be the concentration of that material in the sample. Is it clear so far?
Yes.
Okay, so now let's move to so yeah, UV visible spectroscopy is one of the most versatile, and it is widely applicable for many kind of samples. So yeah, this is one of the most basic instrument. Next is FTIR. So FTIR is used to like it gives you the footprint of any chemical. Say for example you have CH3, CH2, CHO, then there you can have CH3, CHO, then you can have CH3 C double bond COOH. So here you can say that there are different amount of CH3 or CH bond. There are here also it is different. CHO is present here, and here the functional group is different, which is C double bond O, like COOH. So all these groups will have different ways of interacting with infrared radiation. So the amount of infrared radiation that can be absorbed, or at which this particular group is sensitive, or it gives so if this is there can be some stretching vibration. So this bonds can be stretched, like it can be elongated, or there can be some vibrations in the bond, or there can be some bending also, like the bonds can be shortened or the angle can be shortened. So such type of changes you can observe if you like if you have the sample exposed to infrared radiation. So once you start exposing the sample to infrared radiation, you measure what is the amount which is absorbed or which is transmitted by the sample. So you plot transmittance, like what is the amount of transmitted intensity versus what is the wave number. Wave number is nothing but a kind of frequency which is in centimeter inverse. So you will get depending on what type of compound you have, you will get some peaks. So for that, what you do, this is the source for IR. There is a splitter of beam. So there is one fixed mirror which uh, and there is one moving mirror. So all what happens is, so when this comes back, the time which is taken by this fixed mirror, like the light which is reflected from this fixed mirror, it is constant, and the time which is taken by the light to get reflected from this moving mirror will be different. So here again, when it comes back, there will be some interference, or there will be some uh, interference, or sorry, I'm not getting that word. So there will be some kind of interference or addition or subtraction of waves. For example, if the waves are of this, then it will add up, and if waves are of this nature, then it will subtract. Okay, so depending on the type, like at what time moving mirror is reflecting back, there will be some constructive or destructive interference. And when it comes here, depending on the frequency, it will absorb or emit, like the sample will absorb or emit, and detector will capture. Now this detector further amplifies, like there is one amplifier that amplifies the current, and it is further, like since the data is in time domain, you transform it into frequency domain by Fourier transform. So that is how the name of this instrument is Fourier transform infrared radiation. So this is how, based on what transmittance or what type of peaks, or at what frequency or what wave number you are getting the peaks, you will be able to know what type of functional groups or what type of groups are present in that compound. So you will be able to know an unknown compound through this technique. So now let's solve the sample questions for the assignment of this week. So first question is, which one is not a primary pollutant produced by the combustion of fuel? So can you tell me which is not the primary pollutant? So you can say that primary pollutant is the one which is not directly emitted, generated from the source. Yeah?
CO?
Sorry? I could not get you. Can you please repeat? Okay, so primary pollutant.
Smoke?
Yeah, so here,
Smoke?
yeah, smoke is the correct answer. Primary pollutant here is not smoke. All other are primary pollutant because they are directly generated. So if you say fuel, due to combustion, there can be some particulate matter also formed, or there can be generation of carbon dioxide or carbon monoxide, depending on complete or incomplete combustion. Now smoke is generated. Here you can see any city which is having smoke, like this invisibility is due to smoke. So here you can see that say that NOx in the atmosphere, when it combines with volatile organic carbons compounds in the atmosphere, then it gives rise to smoke, which creates certain kind of invisibility in the atmosphere. So here smoke is the correct answer. Next question is, which one is not considered as a physical parameter to measure water quality? So here the answer is hardness, because uh, yeah, temperature, color, you can like aesthetically feel what is it. Hardness, you need to have some measure for that. Okay, so hardness is not a physical parameter. Then what is the percentage error in cation anion balance that can be written as dash?
Cation, sum of cations minus sum of anions divided by sum of cations plus sum of anions into 100.
Yeah,
First one.
that is correct. So this is the correct answer. So here you need to consider that you are taking mode of the charges, like you are not considering the charges that is present, you are just considering the amount of concentration. Okay, so milli equivalent of concentration you need to have, and the summation you take, that needs to be added or subtracted. You are not taking into consideration the charges. Which statement is not correct about water hardness? So first option which is
Decreases the amount of soap needed.
Decreases the amount of soap needed.
yeah, this is the correct answer, because so water hardness, it actually increases the amount of soap needed for cleansing. However, this is not the correct one. So yeah, next is, if water has a higher amount of alkalinity in comparison to total hardness, then the value of non-carbonate hardness will be dash. So here there is one criteria, like I guess I have not mentioned in the previous slide. So as I said, that total hardness is nothing but carbonate hardness plus non-carbonate hardness. So there is alkalinity also of water. So alkalinity, can anyone tell me what you mean by that? So it is a kind of measure of basic, how basic it is, like what type of or what amount of basic um, ions are present. Say for example, OH minus, CO3 2 minus, HCO3 minus. So there is one formula, and depending on what amount of these ions are present, you have some alkalinity or basicity. Okay, so if you have alkalinity less than total hardness, then your carbonate hardness is equal to alkalinity, and if you have total hardness less than alkalinity, then you have carbonate hardness equals to total hardness. So you need to check for alkalinity and total hardness. So whichever is less, that will be taken as carbonate hardness. Okay, and if here what case is given as alkalinity is greater than total hardness, so this is the case, which means that carbonate hardness is equals to total hardness. So since this is equal to carbonate hardness, so you can place this, and which means that non-carbonate hardness, it tends to 0, so it is nothing but 0. Next question is, sodium adsorption ratio is used to evaluate the suitability of water for irrigation, which can be calculated as dash. What could be the answer?
Option 1.
Yeah, I'm sorry, I have mentioned wrong here. Option A is the correct answer. Yeah, here the valency in B, valency of sodium, is wrong. Okay, so moving forward, spectrometric analysis is based on the principle of dash. We discussed this just few slides back. Can anyone tell me?
Interaction of matter with light.
Yeah, so spectroscopic methods are nothing but it involves interaction of matter with light. Next is gas chromatography has become one of the most important tool because of dash.
All of the above.
Yeah, all of the above is the correct answer because it is very simple. It has high sensitivity, which means that for volatile compounds it will be able to separate very precisely and accurately. Yeah, and the ability to effectively separate mixtures. So all of the above is the correct answer. Next is in the FTR analysis, the frequency range is measured as wave number, typically over the range dash centimeter inverse. So yeah, this is the correct answer because any compound gives you vibration or mm, um, vibration in this region, and if you look into infrared radiation range, like wavelength range also, depending on that this will come out to be true because like wavelength will be in nanometer or so, and here you are taking inverse, so depending on that this will come. Next question is find out the DO in milligrams per liter in aerated water at 25 degrees Celsius in a treatment plant. KH is of O2 at 25 degrees centigrade is given as this. KH is here a constant or Henry's constant. So you can say that Henry's law we have to use. Um, can anyone tell me what is Henry's law? Yeah, so Henry's law is used to check for the solubility if you have a partially soluble gas and you need to check for its solubility. So here, since O2 is partially soluble in water, so Henry's law will be applied. So Henry's law states that solubility is equals to Henry's constant, or it is proportional to what pressure that particular component is exerting is proportional to the pressure or like partial pressure of particular component. Okay, so if you remove the proportionality, the constant will arise, which is nothing but Henry's constant and into pressure of that particular component. So here it is for O2, then you can say that solubility of O2 is equals to KH of O2 into partial pressure of O2. Now if you multiply this, then what you will get is into 0.21 atmosphere. So what will remain is solubility in molarity, and what you are asked is DO in milligram per liter. So DO is nothing but soluble amount of oxygen, but you need to just convert the unit. So firstly calculate this, what it comes out as. Is everyone following me?
Yeah.
So this is coming to me as 2.6 10 to the power minus 4 molar. Is everyone getting this answer?
Yes, ma'am.
Yeah. So this is the solubility in molarity, and what you are asked is in milligram per liter. So there is one conversion given to you which says that 1 molar is equals to 32 gram per liter. Now you want in milligram, so let's convert this gram into milligram, which is nothing but 32 into 10 to the power 3, because you need to convert gram into milligram. So 1 gram is 10 to the power 3 milligrams per liter. Okay, so if 1 molar is 32,000 milligram per liter, then what will be 2.6 10 to the power minus 4 molar? Cross calculate this. So it is coming to me nearly as 8.3 milligram per liter. So this is the amount of soluble oxygen in the water. So soluble oxygen is nothing but oxygen which is in dissolved form. So dissolved oxygen concentration is nothing but 8.3 milligram per liter. So nearest option which suits here is 8.4. There can be some deviation because of rounding off. So correct answer is 8.46. So that's it for today. If you have any doubt, you can tell me. Otherwise we can end the session.
Madam, is there any relation between mole fraction and molarity?
Mole fraction and molarity, yeah. You can convert that, like one you can convert into other, definitely. I guess the same question is there for you in the assignment, so it's better you solve it this time. If you are not able to solve, we can solve it in the next class, because like first you need to submit the assignment on your own. So for your exams we can solve.
Thank you.
Anyone else? So if you do not have any doubt, then we can end this session for today. Thank you everyone, thank you for joining. We will meet next week. Thank you everyone.